Far beyond the familiar glow of our sun, where the light fades into a deep, endless twilight, lies a realm of icy mysteries waiting to be uncovered. Picture yourself drifting through the vast, silent expanse of space, where the stars are mere pinpricks of light in an ocean of darkness. Here, in the outer reaches of our solar system, beyond the orbit of Neptune, lies the Kuiper Belt, a cosmic frontier filled with ancient relics from the dawn of our solar system. Imagine a place where dwarf planets, frozen worlds, and icy fragments dance in the cold embrace of space, holding secrets that could rewrite our understanding of how everything began. Tonight, as you settle in, let your mind wander to this distant, enigmatic region, where the whispers of the universe invite you to explore its hidden wonders. What stories do these icy wanderers hold? What clues do they carry about the origins of our solar system? As we journey together through this cosmic tapestry, let the mysteries of the Kuiper Belt lull you into a state of calm curiosity, where the vastness of space becomes a soothing backdrop for your dreams. And as we begin this exploration, tell us, where are you joining us from, and what time is it there? Let's drift into the unknown together. Now, turning to the heart of our cosmic journey, let's explore the Kuiper Belt, a vast, icy frontier that stretches far beyond the orbit of Neptune. Imagine a ring of frozen worlds and ancient debris circling the outer edges of our solar system like a celestial treasure trove. This region, often compared to the asteroid belt, but far larger and colder, is home to countless icy bodies, some of which are dwarf planets like Pluto, Eris, and Haumea. These objects, remnants of the solar system's formation over 4.5 billion years ago, hold clues to how planets like Earth came to be. The Kuiper Belt begins roughly 3 billion miles from the Sun, where the warmth of our star fades into a deep, icy chill. Here, temperatures plummet to hundreds of degrees below freezing, preserving these objects in a state that has remained largely unchanged since the dawn of our solar system. Composed of frozen volatiles like methane, ammonia, and water ice, these bodies are like time capsules, offering scientists a glimpse into the conditions that existed when the planets were still forming. But the Kuiper Belt is more than just a collection of icy relics. It plays a crucial role in the architecture of our solar system. Its gravitational influence helps shape the orbits of distant objects, and its icy inhabitants occasionally venture inward, becoming comets that streak across our skies. This region is also a key to understanding the early solar system, as its objects are thought to be some of the most pristine remnants of the primordial disk from which the planets formed. As we drift deeper into this cosmic frontier, let the image of these icy wanderers fill your mind, each one a silent witness to the birth of our solar system, each one holding secrets waiting to be uncovered. What stories might they tell? What mysteries lie hidden in their frozen cores? The Kuiper Belt is not just a distant region of space. It's a gateway to understanding our cosmic origins. Now, shifting our gaze to the story of its discovery, let's uncover how the Kuiper Belt came to be known to humanity. The tale begins not with a single moment of revelation, but with the gradual piecing together of clues by visionary astronomers. In the mid-20th century, Dutch-American astronomer Gerard Kuiper proposed the idea of a distant region beyond Neptune, populated by icy bodies. Though his initial predictions were met with skepticism, they planted the seeds for what would become one of the most exciting discoveries in modern astronomy. Around the same time, Irish astronomer Kenneth Edgeworth independently theorized about a similar region, suggesting that the outer solar system might be filled with small, icy objects left over from the formation of the planets. Together, their ideas laid the groundwork for what we now call the Kuiper Belt. The real breakthrough, however, came decades later, as technology advanced and telescopes grew more powerful. In the early 1990s, astronomers began to detect faint, slow-moving objects beyond Neptune, confirming the existence of this distant realm. The discovery of the first Kuiper Belt object, later named Albion, marked a turning point. Suddenly, the outer solar system was no longer an empty void, but a bustling region teeming with icy worlds. This revelation sparked a wave of excitement in the scientific community, as researchers realized they were looking at a treasure trove of ancient material, untouched since the solar system's infancy. The discovery of the Kuiper Belt was not just a triumph of human curiosity, but also a testament to the power of technology. Without the development of sensitive detectors and advanced telescopes, these faint, distant objects might have remained hidden forever. Each new observation added to the growing picture of this icy frontier, revealing its complexity and importance in the story of our solar system. As we continue to explore this distant region, we are reminded of the ingenuity and perseverance that brought it to light, a reminder that the universe still holds countless secrets, waiting for us to uncover them. Now turning to the most iconic inhabitant of the Kuiper Belt, we find Pluto, a world that has captured the imagination of millions. Once celebrated as the 9th planet of our solar system, Pluto's story took a dramatic turn in 2006, when the International Astronomical Union reclassified it as a dwarf planet. This decision sparked widespread debate, but it also highlighted the unique nature of this distant world. Pluto's small size and its location within the Kuiper Belt set it apart from the classical planets, yet its complexity and beauty make it no less fascinating. Pluto's surface is a mosaic of icy plains, towering mountains, and vast glaciers, painted in shades of red, white, and brown. One of its most striking features is the heart-shaped region, known as Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. This icy plain, informally called Sputnik Planitia, is thought to be a basin filled with frozen nitrogen, methane, and carbon monoxide. Surrounding it are jagged peaks of water ice, some reaching heights comparable to the Rocky Mountains on Earth. The New Horizons mission, launched in 2006, brought Pluto into sharp focus for the first time. When the spacecraft flew by Pluto in July 2015, it revealed a world far more dynamic and geologically active than anyone had anticipated. Images showed evidence of glaciers flowing, possible cryovolcanoes, and even hints of a subsurface ocean. These discoveries challenged our understanding of small, distant worlds and underscored the importance of the Kuiper Belt as a region of scientific intrigue. Pluto's atmosphere, though thin, adds another layer of mystery. Composed mostly of nitrogen with traces of methane and carbon monoxide, it creates a hazy blue layer that gives the dwarf planet an otherworldly glow. Seasonal changes cause this atmosphere to expand and contract, creating a cycle of freezing and sublimation that shapes Pluto's surface over time. As we reflect on Pluto's journey from planet to dwarf planet, we are reminded that labels do not diminish its significance. Pluto remains a crown jewel of the Kuiper Belt, a world that continues to surprise and inspire. Its story is a testament to the ever-evolving nature of science and the endless wonders waiting to be uncovered in the farthest reaches of our solar system. Now shifting our gaze to another enigmatic figure in the Kuiper Belt, we encounter Eris, a dwarf planet whose discovery reshaped our understanding of the solar system. Found in 2005 by a team led by astronomer Mike Brown, Eris quickly became a focal point of debate. Its size, initially thought to be larger than Pluto, challenged the very definition of a planet, and ultimately led to Pluto's reclassification as a dwarf planet in 2006. This decision, while controversial, highlighted the dynamic and evolving nature of astronomical science. Eris, named after the Greek goddess of strife and discord, lives up to its namesake. It is one of the largest known dwarf planets, with a diameter slightly smaller than Pluto's, but a mass about 27% greater. This makes Eris significantly denser, suggesting a composition rich in rock and ice. Its surface, covered in frozen methane, reflects sunlight brilliantly, making it one of the brightest objects in the Kuiper Belt. This icy sheen, combined with its distance from the sun, gives Eris an almost ghostly appearance as it drifts through the outer reaches of our solar system. The discovery of Eris also brought attention to its moon, Dysnomia, named after the daughter of Eris in Greek mythology. Dysnomia's orbit around Eris provided crucial data for calculating Eris's mass, further solidifying its status as a heavyweight in the Kuiper Belt. The presence of this moon also hints at a complex history of collisions and gravitational interactions that shaped both Eris and its companion. Eris's discovery sparked a heated debate within the astronomical community. Its size and characteristics forced scientists to reconsider the criteria for what constitutes a planet. The International Astronomical Union's decision to reclassify Pluto as a dwarf planet was met with both applause and criticism, but it underscored the importance of Eris in reshaping our understanding of the solar system's architecture. This controversy also opened the door for further exploration and discussion about the nature of celestial bodies in the Kuiper Belt and beyond. As we reflect on Eris's role in this cosmic drama, we are reminded that the universe is full of surprises. Eris, once a catalyst for debate, now stands as a symbol of the ever-changing nature of science and the endless mysteries waiting to be uncovered in the distant reaches of our solar system. Its story, much like Pluto's, invites us to look beyond labels and embrace the complexity and wonder of the cosmos. Now turning our attention to another fascinating resident of the Kuiper Belt, we encounter Haumea, a dwarf planet that defies expectations with its unusual shape and rapid spin. Discovered in 2004 by a team led by astronomer Mike Brown, Haumea stands out as one of the most peculiar objects in our solar system. Unlike the spherical shape typical of most planets and dwarf planets, Haumea is elongated, resembling an egg or a flattened football. This distinctive form is the result of its incredibly fast rotation, completing a full spin in just under 4 hours, one of the quickest rotations of any known object of its size. Haumea's rapid rotation stretches it outward at the equator, creating its unique shape. This high-speed spin also contributes to its dynamic environment, with surface material likely being flung outward due to centrifugal forces. Scientists believe this process may have even led to the formation of its 2 moons, Hi'iaka and Namaka, which orbit Haumea like tiny companions. These moons, named after Hawaiian deities, are thought to have originated from debris ejected during a collision in Haumea's distant past, adding another layer of intrigue to its story. The discovery of Haumea was not without controversy. Initially, 2 teams claimed credit for its identification, one led by Mike Brown and another by Spanish astronomers. The International Astronomical Union ultimately credited the Spanish team with the discovery, naming the dwarf planet after Haumea, the Hawaiian goddess of fertility and childbirth. This naming reflects the cultural significance of the object and its connection to the mythology of the Pacific Islands. Haumea's surface is another source of fascination. Covered in crystalline water ice, it shines brightly, reflecting sunlight with remarkable efficiency. This icy exterior suggests that Haumea has experienced internal heating at some point in its history, possibly due to radioactive decay or the energy from its rapid rotation. Such heating could have caused the ice to melt and refreeze, creating the crystalline structure we observe today. The mysteries surrounding Haumea's formation continue to captivate scientists. Its elongated shape, rapid rotation, and the presence of its moons all point to a violent past, likely involving a massive collision. This event not only shaped Haumea, but also scattered debris across the Kuiper Belt, leaving behind a trail of clues for astronomers to piece together. As we study Haumea, we gain deeper insights into the chaotic processes that shaped the early solar system and the diverse array of objects that inhabit its outer reaches. Haumea's story is a testament to the surprises that await us in the Kuiper Belt. Its unique characteristics challenge our understanding of planetary formation and remind us that the cosmos is filled with wonders that defy our expectations. As we continue to explore this distant region, Haumea stands as a symbol of the dynamic and ever-evolving nature of our solar system. Now shifting our gaze to another intriguing inhabitant of the Kuiper Belt, we encounter Makemake, a dwarf planet that stands out with its striking reddish hue and enigmatic nature. Discovered in 2005 by a team led by astronomer Mike Brown, Makemake quickly captured the attention of scientists and space enthusiasts alike. Named after the creator deity of the Rapa Nui people of Easter Island, Makemake embodies the spirit of discovery and the mysteries that lie in the outer reaches of our solar system. Makemake's most distinctive feature is its reddish surface, a characteristic that sets it apart from many other Kuiper Belt objects. This reddish tint is believed to be caused by the presence of tholins, complex organic molecules formed when ultraviolet light interacts with methane on its surface. These tholins give Makemake a unique coloration, making it one of the most visually striking objects in the Kuiper Belt. The presence of methane also suggests that Makemake's surface is extremely cold, with temperatures plummeting to around minus 240 degrees Celsius, creating an environment where methane can exist as a frozen solid. Unlike some of its Kuiper Belt neighbors, Makemake appears to lack a significant atmosphere. Observations from ground-based telescopes and the Hubble Space Telescope have revealed no evidence of a substantial gaseous envelope surrounding the dwarf planet. This absence of an atmosphere is somewhat surprising, given that other similarly sized objects, like Pluto, possess thin atmospheres. Scientists speculate that Makemake's lack of an atmosphere could be due to its distance from the Sun, which prevents the sublimation of surface ices into gas. Alternatively, its surface composition or internal processes might play a role in this atmospheric void. The discovery of Makemake was a milestone in our understanding of the Kuiper Belt. It was one of the first objects identified in this distant region after Pluto and Eris, highlighting the diversity of bodies that populate this icy frontier. Makemake's size, roughly 2/3 that of Pluto, and its unique characteristics have made it a key subject of study for astronomers seeking to unravel the complexities of the outer solar system. Its discovery also underscored the importance of continued exploration and observation, as each new object adds another piece to the puzzle of our cosmic neighborhood. Makemake's significance extends beyond its physical properties. It serves as a reminder of the vast and varied nature of the Kuiper Belt, a region that continues to surprise us with its diversity. From its reddish surface to its lack of atmosphere, Makemake challenges our assumptions and invites us to rethink what we know about the formation and evolution of distant worlds. As we study this enigmatic dwarf planet, we gain not only a deeper understanding of the Kuiper Belt, but also a greater appreciation for the wonders that await us in the far reaches of our solar system. Makemake's story is one of discovery, mystery, and the relentless pursuit of knowledge. It reminds us that even in the cold, dark expanse of the Kuiper Belt, there are worlds that shine with their own unique light, waiting to reveal their secrets to those who dare to look. As we continue to explore this distant region, Makemake stands as a testament to the endless possibilities that lie beyond the familiar confines of our inner solar system. Now turning our attention to another fascinating resident of the Kuiper Belt, we encounter Quaoar, a distant wanderer that has intrigued astronomers since its discovery. Found in 2002 by the same team led by Mike Brown, Quaoar quickly became a subject of interest due to its size and unique characteristics. Named after the creator god of the Tongva people, indigenous to the Los Angeles region, Quaoar carries a sense of cultural significance alongside its scientific importance. Quaoar is one of the larger objects in the Kuiper Belt, with a diameter of roughly 1,100 kilometers, making it about half the size of Pluto. Its substantial size places it among the most significant bodies in this icy region, and its discovery further highlighted the diversity of objects beyond Neptune. What makes Quaoar particularly intriguing is the presence of its moon, Quaoar, discovered in 2006. This small companion orbits Quaoar at a distance, adding another layer of complexity to our understanding of these distant worlds. One of the most captivating aspects of Quaoar is the possibility that it might possess a ring system. Observations from ground-based telescopes and the Hubble Space Telescope have hinted at the presence of material orbiting Quaoar, potentially forming a faint ring. This would be a remarkable discovery, as rings are typically associated with giant planets like Saturn, rather than smaller Kuiper Belt objects. If confirmed, Quaoar's ring system would challenge our assumptions about how and where such features can form, offering new insights into the dynamics of these remote regions. The discovery of Quaoar and its potential ring system underscores the importance of continued exploration and observation in the Kuiper Belt. Each new finding adds to our understanding of the processes that shaped the early solar system and the diversity of objects that inhabit its outer reaches. Quaoar's size, its moon, and the tantalizing possibility of rings make it a key subject for future studies, as astronomers seek to unravel the mysteries of this distant wanderer. Quaoar's story is one of discovery and the ongoing quest to understand the complexities of our cosmic neighborhood. It reminds us that even in the cold, dark expanse of the Kuiper Belt, there are worlds that hold secrets waiting to be uncovered. As we continue to explore this distant region, Quaoar stands as a testament to the endless possibilities that lie beyond the familiar confines of our inner solar system, inviting us to look deeper and dream bigger. Now shifting our gaze to the outermost edges of the Kuiper Belt, we encounter Sedna, a solitary wanderer whose existence challenges our understanding of the solar system's boundaries. Discovered in 2003 by a team led by astronomer Mike Brown, Sedna immediately stood out due to its extraordinary orbit. Unlike most objects in the Kuiper Belt, which follow relatively circular paths, Sedna's orbit is highly elongated, taking it on a journey that stretches far beyond the known limits of our cosmic neighborhood. Sedna's orbit is so vast that at its farthest point, it reaches a staggering distance of over 937 astronomical units from the Sun. To put that into perspective, 1 astronomical unit is the average distance between Earth and the Sun, meaning Sedna ventures nearly 1,000 times farther out than our planet. At its closest approach, it still remains far beyond the orbit of Neptune, never coming close enough to interact with the giant planets. This extreme orbit makes Sedna one of the most distant known objects in the solar system, earning it the nickname, the Lone Wanderer. The discovery of Sedna raised profound questions about its origins. How did an object of its size end up in such a distant and isolated orbit? One leading theory suggests that Sedna's journey was shaped by gravitational interactions with a passing star in the early days of the solar system. As this star passed by, its gravitational pull could have tugged Sedna outward, placing it on its current path. Another possibility is that Sedna was influenced by an undiscovered planet lurking in the outer reaches of the solar system, a hypothetical world often referred to as Planet 9. This mysterious planet, if it exists, could have altered Sedna's orbit, sending it into the distant reaches where it now resides. Sedna's surface also holds clues to its past. Observations reveal that it has a reddish hue, likely due to the presence of complex organic molecules called tholins, which form when sunlight interacts with methane and other ices over billions of years. This suggests that Sedna has remained relatively unchanged since the early days of the solar system, making it a pristine relic of that ancient era. Its surface temperature is among the coldest in the solar system, hovering just a few degrees above absolute zero, further emphasizing its isolation. The story of Sedna is one of mystery and intrigue. Its distant orbit and enigmatic origins challenge our understanding of how the solar system formed and evolved. As astronomers continue to study this lone wanderer, they hope to uncover more about the forces that shaped its path and the secrets it holds about the outer reaches of our cosmic neighborhood. Sedna reminds us that even in the farthest corners of the solar system, there are worlds waiting to reveal their stories, inviting us to explore the unknown and expand our understanding of the universe. Now, as we venture even deeper into the Kuiper Belt, we come across Arrokoth, a fascinating object that has captured the imagination of astronomers and space enthusiasts alike. Known affectionately as the snowman of space, Arrokoth is the most distant object ever visited by a spacecraft, offering us a rare glimpse into the early days of our solar system. Its discovery and subsequent exploration by the New Horizons mission have provided invaluable insights into how planetary bodies formed billions of years ago. Arrokoth's unique shape is one of its most striking features. It consists of two distinct lobes that appear to be gently fused together, resembling a snowman. This bilobed structure suggests that Arrokoth formed through a slow and gentle collision between two smaller objects, rather than a violent impact. This process, known as accretion, is thought to be how many of the building blocks of planets came together in the early solar system. The smooth, unblemished surface of Arrokoth indicates that it has remained largely undisturbed since its formation, making it a pristine time capsule from that ancient era. The New Horizons mission, which famously flew by Pluto in 2015, made history again in 2019 when it conducted a close flyby of Arrokoth. This daring maneuver provided scientists with unprecedented data about this distant world. The spacecraft's instruments revealed that Arrokoth's surface is covered in a mix of water ice, methanol, and complex organic molecules. These findings suggest that the building blocks of life may have been present in the outer reaches of the solar system, raising intriguing questions about the origins of life on Earth. One of the most significant discoveries from the New Horizons mission is that Arrokoth's two lobes have nearly identical compositions, indicating that they formed in the same region of the solar system. This supports the idea that planetesimals, the precursors to planets, formed through the gradual accumulation of material in a relatively calm and stable environment. Arrokoth's gentle formation process contrasts sharply with the chaotic and violent collisions that shaped the inner solar system, highlighting the diversity of planetary formation mechanisms. Arrokoth's reddish hue, similar to that of other Kuiper Belt objects, is likely due to the presence of tholins, complex organic molecules that form when ultraviolet light interacts with simple ices over long periods. This coloration provides further evidence that Arrokoth has remained largely unchanged since its formation, preserving clues about the conditions in the early solar system. Its surface is also remarkably smooth, with few craters, suggesting that it has experienced little disruption over billions of years. The exploration of Arrokoth has deepened our understanding of the Kuiper Belt and the processes that shaped our solar system. By studying this distant object, scientists have gained new insights into how planetesimals formed and evolved, shedding light on the origins of planets like Earth. Arrokoth's story is a testament to the enduring mysteries of the outer solar system and the importance of continued exploration. As we uncover more about this distant world, we are reminded of the vastness of space and the countless secrets it still holds, waiting to be discovered. Now, as we shift our gaze to the icy heart of the Kuiper Belt, we uncover a world frozen in time, where the secrets of the early solar system are preserved in a delicate dance of frost and light. The Kuiper Belt is a treasure trove of frozen volatiles, substances like methane, ammonia, and water that exist as ices in the frigid temperatures of this distant region. These icy bodies are more than just remnants of the past. They are time capsules, holding clues to the conditions that shaped our solar system over 4.5 billion years ago. The icy composition of Kuiper Belt objects is a direct result of their location, far from the sun's warming rays. In this cold, dark expanse, temperatures hover just a few degrees above absolute zero, allowing volatile compounds to remain frozen solid. Methane, for instance, which would evaporate quickly in the inner solar system, remains stable here, coating the surfaces of these distant worlds in a shimmering frost. Ammonia and water, too, are locked in icy layers, creating landscapes that are both alien and eerily familiar. These ices are not just frozen remnants, they are storytellers. The presence of methane and ammonia, for example, suggests that the Kuiper Belt formed in a region rich in these compounds, likely far from the sun's heat. Water ice, on the other hand, is a universal building block found throughout the solar system. Its presence in the Kuiper Belt hints at a shared origin with other icy bodies, such as comets and the moons of the outer planets. By studying these ices, scientists can piece together the chemical makeup of the early solar system and trace the journey of these materials from their formation to their current resting places. One of the most fascinating aspects of these icy compositions is how they have remained largely unchanged over billions of years. The Kuiper Belt's distance from the sun has shielded its objects from the intense heat and radiation that have altered the surfaces of planets and moons closer to the sun. This preservation allows scientists to study these ices in their most primordial state, offering a window into the conditions that existed when the solar system was young. For example, the reddish hue seen on many Kuiper Belt objects, caused by Thalin's complex organic molecules formed when ultraviolet light interacts with simple ices, provides evidence of the chemical processes that occurred in the early solar system. The icy nature of the Kuiper Belt also has implications for our understanding of planetary formation. The gentle accretion of these frozen materials, as seen in objects like Arrokoth, suggests that the outer solar system was a relatively calm and stable environment compared to the chaotic collisions that shaped the inner planets. This contrast highlights the diversity of processes that contributed to the formation of our solar system, from the fiery birth of rocky planets to the serene assembly of icy worlds. As we continue to explore the Kuiper Belt, these icy compositions will undoubtedly reveal even more about the origins of our solar system. Each frozen grain of methane, each crystal of water ice, holds a piece of the story, a story that began billions of years ago and continues to unfold with every new discovery. The Kuiper Belt's icy treasures remind us that even in the coldest, darkest corners of space, there is warmth in the knowledge that we are uncovering the secrets of our cosmic past. Now, as we turn our attention to the dynamic relationship between the Kuiper Belt and comets, we uncover a fascinating link that ties these icy wanderers to the distant reaches of our solar system. The Kuiper Belt is not just a collection of frozen relics, it is also the birthplace of some of the most spectacular comets that grace our skies. These comets, with their glowing tails and dramatic appearances, are messengers from the outer solar system, carrying with them clues about the history and evolution of our cosmic neighborhood. Comets that originate from the Kuiper Belt are often referred to as short-period comets, meaning they complete their orbits around the Sun in less than 200 years. These comets are thought to have been nudged out of their stable orbits in the Kuiper Belt by gravitational interactions, sending them on a journey inward toward the Sun. As they approach the inner solar system, the heat from the Sun causes their icy surfaces to vaporize, creating the glowing coma and tail that make comets so mesmerizing to observe. The journey of these comets is more than just a celestial spectacle. It is a window into the past. The ices and dust that make up comets are some of the most pristine materials in the solar system, preserved in the deep freeze of the Kuiper Belt for billions of years. When a comet's ices vaporize, they release gases and dust that contain chemical signatures from the early solar system. By studying these materials, scientists can learn about the conditions that existed when the solar system was forming, including the types of molecules present and the processes that shape them. One of the most famous comets thought to have originated in the Kuiper Belt is Halley's Comet. This iconic comet, which returns to the inner solar system roughly every 76 years, is believed to have been perturbed from its original orbit in the Kuiper Belt long ago. Its periodic visits provide scientists with repeated opportunities to study its composition and behavior, offering insights into the nature of comets and their origins. The connection between Kuiper Belt objects and comets also highlights the dynamic nature of the solar system. Gravitational interactions, collisions, and other forces continually reshape the orbits of these icy bodies, sending some on journeys toward the Sun, while others remain in the distant reaches of the Kuiper Belt. This constant movement and interaction remind us that the solar system is not a static place, but a dynamic and ever-changing environment. As we continue to explore the Kuiper Belt and study the comets that originate there, we gain a deeper understanding of the processes that have shaped our solar system over billions of years. Each comet that streaks across our sky is a reminder of the intricate connections between the distant Kuiper Belt and the world we call home. These icy travelers not only illuminate our nights, but also illuminate the history of our solar system, carrying with them the stories of a time long before the planets took their current forms. Now, as we venture further into the outer reaches of the Kuiper Belt, we encounter a region that defies the orderly patterns of the solar system, the scattered disk. This chaotic and enigmatic zone is home to some of the most peculiar objects in our cosmic neighborhood, with orbits that stretch far beyond the more stable regions of the Kuiper Belt. Unlike the relatively circular paths of many Kuiper Belt objects, the orbits of scattered disk objects are highly elongated and tilted, making them appear as if they were flung outward by some unseen force. The scattered disk is thought to be the result of gravitational interactions with the giant planets, particularly Neptune. As these planets formed and migrated to their current positions, their immense gravity likely disturbed the orbits of nearby icy bodies, sending some of them into the distant and erratic paths we see today. This process created a region where objects follow wildly eccentric orbits, sometimes swinging close to the sun before being hurled back into the frigid depths of space. Among the most famous inhabitants of the scattered disk are Eris and Sedna, two objects that have captured the attention of astronomers and the public alike. Eris, discovered in 2005, is slightly larger than Pluto and played a key role in the reclassification of Pluto as a dwarf planet. Its highly inclined orbit takes it far beyond the Kuiper Belt, into the scattered reaches of the solar system. Sedna, on the other hand, is even more extreme. Discovered in 2003, Sedna follows an orbit so elongated that it takes more than 11,000 years to complete a single trip around the Sun. At its farthest point, Sedna ventures into a region so distant that it challenges our understanding of the solar system's boundaries. The chaotic nature of the scattered disk raises intriguing questions about the history and evolution of our solar system. How did these objects end up in such extreme orbits? What forces shaped their paths? And what can they tell us about the early days of planetary formation? Some scientists speculate that the scattered disk may hold clues to the existence of an undiscovered planet, often referred to as Planet 9, whose gravity could be influencing the orbits of these distant objects. As we study the scattered disk and its inhabitants, we are reminded of the dynamic and ever-changing nature of the solar system. This region, with its unpredictable orbits and mysterious origins, serves as a testament to the powerful forces that have shaped our cosmic neighborhood over billions of years. It is a place where the past and present collide, offering us a glimpse into the processes that continue to shape the universe around us. And as we peer into this chaotic frontier, we are left to wonder what other secrets it might hold, waiting to be uncovered by the next generation of explorers. Now, as we journey even deeper into the mysteries of the Kuiper Belt, we encounter a phenomenon that has puzzled astronomers for decades: the Kuiper Cliff. This abrupt and unexplained boundary marks a sudden drop-off in the number of objects beyond a certain distance from the Sun. It's as if the Kuiper Belt, which has been teeming with icy bodies and dwarf planets, simply ends, leaving a vast and empty expanse beyond. This cosmic cliff raises profound questions about the structure and history of our solar system, and it has become one of the most intriguing puzzles in modern astronomy. The Kuiper Cliff is located roughly 50 astronomical units from the Sun, or about 50 times the distance between Earth and the Sun. Beyond this point, the number of objects detected drops dramatically, creating a sharp boundary that defies expectations. Scientists had predicted that the Kuiper Belt would gradually thin out as they moved farther from the sun, but the suddenness of this drop-off has left them searching for answers. What could cause such a stark change in the population of objects? Why does the Kuiper Belt seem to have a hard edge? One of the leading theories suggests that the Kuiper Cliff might be the result of gravitational interactions with an undiscovered planet lurking in the outer reaches of the solar system. This hypothetical world, often referred to as Planet 9, could have swept through the region in the distant past, clearing out objects and leaving behind the sharp boundary we observe today. The gravitational influence of such a planet could explain not only the Kuiper Cliff, but also the unusual orbits of some distant objects, like Sedna and Eris, which seem to be tugged by an unseen force. Another possibility is that the Kuiper Cliff marks the outer edge of the primordial disk of material from which the solar system formed. In this scenario, the early solar system may have had a natural boundary beyond which material was too sparse to form large objects. Over time, the gravitational influence of the giant planets could have further sculpted this region, creating the sharp drop-off we see today. However, this explanation still leaves many questions unanswered, particularly about why the boundary is so abrupt and well-defined. The Kuiper Cliff also raises intriguing questions about the history of our solar system. Could it be evidence of a past collision or a close encounter with another star? Some scientists have speculated that a passing star, billions of years ago, might have stripped away material from the outer edges of the Kuiper Belt, leaving behind the cliff we observe today. While this idea is speculative, it highlights the dynamic and ever-changing nature of our cosmic neighborhood. As we continue to study the Kuiper Cliff, we are reminded of how much we still have to learn about the outer reaches of our solar system. This mysterious boundary challenges our understanding of planetary formation and the forces that shape the cosmos. It serves as a reminder that even in the seemingly quiet and distant regions of space, there are still secrets waiting to be uncovered. And as we peer into the void beyond the Kuiper Cliff, we are left to wonder what other surprises might lie hidden in the darkness, waiting for the next generation of explorers to reveal them. Now, as we venture further into the outer reaches of our solar system, we turn our attention to one of the most tantalizing mysteries of modern astronomy, Planet 9. This hypothetical giant, thought to reside far beyond the Kuiper Belt, has captured the imagination of scientists and stargazers alike. The idea of a hidden planet lurking in the shadows of our cosmic neighborhood is not just the stuff of science fiction. It's a serious scientific hypothesis backed by intriguing evidence. The story of Planet 9 begins with the peculiar orbits of some distant objects in the Kuiper Belt. Objects like Sedna and Eris, which we've discussed earlier, follow paths that seem to be influenced by something massive and unseen. Their orbits are tilted and elongated in ways that can't easily be explained by the gravitational pull of the known planets. This has led astronomers to propose the existence of a ninth planet, one that could be up to 10 times the mass of Earth, orbiting the Sun at a distance hundreds of times farther than Neptune. The evidence for Planet 9 is indirect but compelling. Computer simulations have shown that the gravitational influence of such a planet could explain the unusual clustering of orbits observed in the outer solar system. These simulations suggest that Planet 9's presence would cause distant objects to align in a specific pattern, much like a cosmic shepherd guiding its flock. While no one has yet seen this elusive world, the mathematical predictions and orbital anomalies point strongly to its potential existence. The search for Planet 9 is a monumental challenge. Its extreme distance from the Sun means it would reflect very little light, making it incredibly faint and difficult to detect. Astronomers are using some of the most advanced telescopes in the world, like the Subaru telescope in Hawaii, to scan the skies for this hidden giant. The search is painstaking, requiring years of observation and analysis, but the potential discovery of Planet 9 would revolutionize our understanding of the solar system. If Planet 9 does exist, it could provide answers to many of the mysteries we've explored so far. Its gravitational influence might explain the Kuiper Cliff, the strange orbits of distant objects, and even the distribution of material in the outer solar system. It could also offer clues about the early history of our cosmic neighborhood, shedding light on how the planets formed and evolved over billions of years. As we continue to search for this hypothetical giant, we are reminded of the vastness of our solar system and the secrets it still holds. Planet 9 represents not just a missing piece of the puzzle, but a reminder that there is still so much to discover. Whether it's a massive world waiting to be found, or simply a fascinating idea that pushes the boundaries of our knowledge, the quest for Planet 9 keeps us looking to the stars, eager to uncover the next great cosmic revelation. As we shift our gaze to the origins of our cosmic neighborhood, the Kuiper Belt emerges as a time capsule, offering a glimpse into the early days of the solar system. This distant region, filled with icy remnants and ancient debris, holds clues to how the planets, including our own, came to be. The Kuiper Belt is not just a collection of frozen worlds, it's a treasure trove of primordial material, preserved in the deep freeze of space for billions of years. The story of the solar system's formation begins with a swirling cloud of gas and dust, collapsing under its own gravity to form the Sun. Around this newborn star, tiny particles began to clump together, growing into larger bodies called planetesimals. These building blocks of planets collided, merged, and eventually formed the worlds we know today. But not all of these planetesimals were destined to become planets. Some were flung outward by the gravitational tug of giant planets like Jupiter and Neptune, settling in the cold, dark reaches of the Kuiper Belt. This distant region acts as a cosmic archive, preserving the raw materials from which the solar system was built. The icy bodies of the Kuiper Belt are like frozen snapshots of the early solar system, containing compounds such as methane, ammonia, and water that have remained unchanged for eons. By studying these objects, scientists can piece together the conditions that existed when the planets were forming, shedding light on the processes that shaped our cosmic home. The Kuiper Belt also plays a crucial role in understanding the dynamics of planetary formation. The gravitational interactions that scattered these objects to the outer solar system reveal how the giant planets migrated and reshaped the early solar system. This migration likely influenced the distribution of material, carving out the orbits of planets and leaving behind the Kuiper Belt as a relic of that turbulent era. Moreover, the Kuiper Belt's icy bodies may hold the key to understanding the origins of water and organic molecules on Earth. Some scientists believe that comets originating from the Kuiper Belt could have delivered these essential ingredients to our planet, setting the stage for life to emerge. This connection between the distant Kuiper Belt and our own world underscores the interconnectedness of the solar system. As we explore the Kuiper Belt, we are not just uncovering the secrets of distant worlds, we are tracing the story of our own origins. Each icy body, each fragment of primordial material, adds another piece to the puzzle of how the solar system came to be. The Kuiper Belt is more than a frontier of exploration. It's a window into the past, offering us a chance to understand the forces that shaped our cosmic neighborhood and ultimately ourselves. With this deeper understanding of the Kuiper Belt's role in solar system formation, we now turn our attention to the missions that have ventured into this distant realm, revealing its secrets and paving the way for future discoveries. As we venture further into the mysteries of the Kuiper Belt, it's time to shine a light on the missions that have brought us closer to understanding this distant frontier. The journey to explore the Kuiper Belt has been one of ingenuity, perseverance, and groundbreaking discoveries, with the New Horizons mission standing as a landmark achievement. Launched in 2006, New Horizons became the first spacecraft to visit Pluto, revealing its stunning surface features and transforming our understanding of this distant world. But its journey didn't end there. After its historic flyby of Pluto in 2015, New Horizons continued its voyage deeper into the Kuiper Belt, encountering Arrokoth, a primordial object that offered a glimpse into the solar system's earliest days. This mission has not only expanded our knowledge of the Kuiper Belt, but also demonstrated the incredible potential of robotic exploration in the farthest reaches of our solar system. Looking ahead, the future of Kuiper Belt exploration holds even more promise. Scientists and engineers are already planning new missions to uncover the secrets of this icy realm. One proposed mission aims to send a spacecraft to study multiple Kuiper Belt objects, providing a broader understanding of their composition, structure, and origins. Another ambitious idea involves sending a probe to orbit a dwarf planet like Pluto or Eris, allowing for long-term observations and detailed mapping of these distant worlds. These future missions will build on the legacy of New Horizons, pushing the boundaries of what we know about the outer solar system. However, exploring the Kuiper Belt is no small feat. The immense distances involved pose significant challenges, requiring spacecraft to travel for years, even decades, to reach their destinations. The extreme cold and low light levels in this region also demand advanced technology to ensure the survival and functionality of scientific instruments. Additionally, the limited communication windows between Earth and these distant probes mean that the transmission can be slow and intermittent, requiring careful planning and patience from mission teams. Despite these hurdles, the scientific rewards of exploring the Kuiper Belt are immense, offering insights into the formation of the solar system and the potential for discovering new worlds. As we look to the future, the Kuiper Belt remains a frontier of discovery, beckoning us to uncover its hidden secrets. Each mission, past and future, brings us closer to understanding the origins of our cosmic neighborhood and the forces that shaped it. With every new discovery, we not only expand our knowledge of the universe, but also deepen our connection to the vast, mysterious expanse of space. And as we continue to explore, the Kuiper Belt reminds us that the journey of discovery is never truly over. As we turn our gaze to the icy expanse of the Kuiper Belt, a fascinating question arises. Could this distant region hold the key to life beyond Earth? While the Kuiper Belt may seem like a frozen wasteland, its icy bodies might harbor secrets that challenge our understanding of where life can thrive. One of the most intriguing possibilities is the existence of subsurface oceans beneath the frozen surfaces of some Kuiper Belt objects. These hidden reservoirs of liquid water, kept warm by the decay of radioactive elements or the gravitational tug of nearby moons, could provide the perfect environment for life to emerge and persist. Take, for example, the dwarf planet Pluto. Data from the New Horizons mission revealed signs of geological activity, including the potential for a subsurface ocean beneath its icy shell. If such an ocean exists, it could contain the necessary ingredients for life, such as organic molecules and energy sources. Similar conditions might be found on other Kuiper Belt objects, like Eris or Makemake, where the combination of heat and chemistry could create habitable niches in the most unexpected places. These icy worlds, once thought to be barren and lifeless, might instead be teeming with possibilities. The implications of finding life in the Kuiper Belt would be profound. It would suggest that life is not confined to the warm, sunlit regions of the solar system, but could exist in the coldest, darkest corners as well. This would expand our understanding of habitability and open new avenues in the search for extraterrestrial life. If life can thrive in the Kuiper Belt, it might also exist in similar environments elsewhere in the universe, such as the icy moons of Jupiter and Saturn, or even the distant exoplanets orbiting other stars. Of course, the search for life in the Kuiper Belt is not without its challenges. The extreme distances and harsh conditions make it difficult to study these objects in detail. Future missions will need advanced technology to penetrate the icy surfaces and explore the potential oceans below, but the rewards could be extraordinary, offering insights not only into the origins of life in our solar system, but also into the broader question of whether we are alone in the cosmos. As we ponder the mysteries of the Kuiper Belt, we are reminded that the universe is full of surprises. What once seemed like a frozen, lifeless region might hold the key to one of humanity's greatest questions. Are we alone? With each new discovery, we move closer to answering this question, and the Kuiper Belt, with its hidden oceans and icy secrets, stands as a frontier of possibility in our ongoing quest to understand the cosmos. Now shifting our gaze even further into the depths of our solar system, we encounter another enigmatic region, the Oort cloud. While the Kuiper Belt lies just beyond Neptune, the Oort cloud is a vast spherical shell of icy objects that stretches far beyond the Kuiper Belt, reaching nearly halfway to the nearest star. Together, these two regions form the outermost boundaries of our solar system, each holding its own unique mysteries and treasures. The Kuiper Belt and the Oort cloud share some similarities, primarily in their composition. Both are home to countless icy bodies, remnants of the early solar system that never coalesced into planets. These objects are like frozen time capsules, preserving clues about the conditions and materials present during the formation of our cosmic neighborhood. However, their differences are just as striking. The Kuiper Belt is relatively flat and disk-like, lying in the same plane as the planets, while the Oort cloud is a spherical shell that surrounds the entire solar system. This difference in shape hints at their distinct origins and histories. The objects within these regions also vary significantly. The Kuiper Belt is populated by dwarf planets like Pluto, Eris, and Haumea, as well as smaller icy bodies that occasionally venture inward as comets. These objects tend to have more stable orbits and are influenced by the gravitational pull of Neptune. In contrast, the Oort cloud is thought to contain trillions of icy fragments, many of which are so distant that they are barely bound by the sun's gravity. These objects are often nudged by passing stars or galactic tides, sending them on long, looping journeys into the inner solar system as long-period comets. One of the most fascinating aspects of the Oort cloud is its sheer scale. While the Kuiper Belt extends to about 50 times the distance from the Sun to Earth, the Oort cloud begins where the Kuiper Belt ends and stretches out to a staggering 100,000 times that distance. This immense expanse makes the Oort cloud one of the most remote and least understood regions of our solar system. Its objects are so far away that they have never been directly observed, and their existence is inferred from the trajectories of comets that originate there. Despite their differences, both the Kuiper Belt and the Oort cloud play crucial roles in shaping our understanding of the solar system's history. The Kuiper Belt offers a closer, more accessible window into the early stages of planetary formation, while the Oort cloud provides a glimpse into the chaotic processes that shape the outer reaches of our cosmic neighborhood. Together, they remind us that the solar system is not just a collection of planets and moons, but a dynamic, interconnected system with stories waiting to be uncovered. As we explore these distant regions, we are reminded of the vastness of space and the endless possibilities it holds. The Kuiper Belt and the Oort cloud, though separated by immense distances, are both part of the same cosmic tapestry, weaving together the story of our solar system's past, present, and future. And as we continue to study them, we inch closer to unraveling the secrets they hold, bringing us one step closer to understanding our place in the universe. Now turning to the influence of the Kuiper Belt beyond the realm of science, let's explore how this distant region has captured the imagination of storytellers and creators across popular culture. The Kuiper Belt, with its icy mysteries and uncharted worlds, has become a fertile ground for science fiction, inspiring tales of exploration, discovery, and the unknown. From blockbuster movies to gripping novels, this cosmic frontier has shaped how we envision the outer reaches of our solar system and beyond. In movies, the Kuiper Belt often serves as a backdrop for stories of interstellar adventure and danger. Its icy bodies and vast emptiness provide a perfect setting for narratives about humanity's quest to explore the farthest corners of space. Films and TV shows have depicted the Kuiper Belt as a place where ancient secrets lie hidden, or where humanity might encounter alien civilizations. These portrayals, while often dramatized, have helped bring the concept of the Kuiper Belt into the public consciousness, sparking curiosity about what might truly exist in this distant region. Books, too, have embraced the Kuiper Belt as a source of inspiration. Science fiction authors have imagined it as a place of wonder, where humanity might find new resources, uncover ancient artifacts, or even establish colonies. The Kuiper Belt's remoteness and the challenges of reaching it make it a compelling setting for stories about perseverance, ingenuity, and the human spirit. These narratives not only entertain, but also encourage readers to think about the possibilities of space exploration and the mysteries that await us in the outer solar system. Beyond fiction, the Kuiper Belt has also influenced how we perceive space exploration in real life. The discoveries of objects like Pluto, Eris, and Arrokoth have captured the public's imagination, reminding us that there is still so much to learn about our own cosmic backyard. Missions like New Horizons, which provided stunning images of Pluto and Arrokoth, have brought the Kuiper Belt into the spotlight, showing that even the most distant regions of our solar system are within our reach. These achievements have inspired a new generation of scientists, engineers, and dreamers to look to the stars and imagine what lies beyond. The Kuiper Belt's presence in popular culture has also shaped how we think about the future of space exploration. It has become a symbol of humanity's potential to push the boundaries of knowledge and technology, to venture into the unknown and uncover the secrets of the universe. Whether through the lens of fiction or the achievements of real-world missions, the Kuiper Belt continues to inspire us to dream bigger and reach further. As we reflect on the Kuiper Belt's role in popular culture, we see how it bridges the gap between science and imagination. It reminds us that the mysteries of the cosmos are not just the domain of astronomers and spacecraft, but also of storytellers and dreamers. And as we continue to explore this distant region, both in reality and in fiction, we are reminded of the endless possibilities that lie beyond the horizon, waiting to be discovered. Now shifting our gaze to the companions of these distant worlds, let's delve into the fascinating moons that orbit Kuiper Belt objects. These moons, often overlooked in the shadow of their larger parent bodies, hold secrets of their own, offering clues about the history and formation of the Kuiper Belt itself. Each moon is a world unto itself, with unique features and stories that add depth to our understanding of this icy frontier. Take, for example, Charon, Pluto's largest moon. Discovered in 1978, Charon is so massive relative to Pluto that the two are often considered a binary system, orbiting a shared center of gravity. Charon's surface is marked by deep canyons and a reddish-brown hue, hinting at complex geological processes and the presence of organic compounds. Its discovery not only reshaped our understanding of Pluto, but also raised questions about how such a large moon could form in the outer solar system. Then there's Dysnomia, the moon of Eris. This small, dim companion was discovered in 2005, shortly after Eris itself. Dysnomia's orbit provides crucial information about Eris's mass and density, helping astronomers piece together the story of how these distant worlds came to be. Its existence also underscores the diversity of the Kuiper Belt, where even the smallest objects can have moons of their own. Haumea, the egg-shaped dwarf planet, boasts not one but two moons, Hiaka and Namaka. These moons are thought to have formed from debris ejected during a collision in Haumea's distant past. Their orbits are tilted and eccentric, offering a glimpse into the chaotic events that shaped this unusual family of objects. The presence of these moons also suggests that collisions were common in the early Kuiper Belt, playing a key role in sculpting its current landscape. Makemake, though moonless for many years, surprised astronomers in 2016 with the discovery of a small moon, later named MK2. This faint companion, barely visible against the darkness of space, has sparked new interest in Makemake and its potential to hold more secrets. Its discovery reminds us that even the most well-studied objects in the Kuiper Belt can still surprise us. The moons of Kuiper Belt objects are more than just celestial curiosities. They are windows into the past, preserving evidence of the collisions, gravitational interactions, and other processes that shape the outer solar system. By studying these moons, scientists can piece together the history of the Kuiper Belt and the forces that have influenced its evolution over billions of years. As we continue to explore these distant worlds and their companions, we are reminded of the complexity and richness of the Kuiper Belt. Each moon tells a story, and together they form a tapestry of discovery that deepens our understanding of the cosmos. With every new observation and mission, we uncover more about these icy worlds and the moons that orbit them, bringing us closer to unraveling the mysteries of the outer solar system. Now turning to the profound ways the Kuiper Belt has shaped our own world, we find a story of cosmic connections that stretch across the solar system. While the Kuiper Belt may seem like a distant, icy realm, its influence on Earth is far more significant than one might imagine. This region, filled with ancient remnants from the solar system's formation, has played a crucial role in delivering the building blocks of life to our planet. One of the most fascinating ways the Kuiper Belt has impacted Earth is through comets. Many comets originate in the Kuiper Belt, carrying with them frozen water and organic molecules. As these comets journey inward toward the Sun, some collide with Earth, depositing these essential ingredients. Scientists believe that over billions of years, these impacts may have contributed to the water that fills our oceans and the organic compounds that spark the beginnings of life. In this way, the Kuiper Belt is not just a distant collection of icy bodies, but a vital part of Earth's history. The interconnectedness of the solar system becomes even more apparent when we consider how the Kuiper Belt's objects have influenced Earth's environment. For example, the gravitational interactions between Kuiper Belt objects and the giant planets, like Neptune and Jupiter, can send comets hurtling toward the inner solar system. These comets, in turn, have the potential to alter Earth's climate and even shape the course of evolution. A single comet impact could have profound effects, from triggering mass extinctions to creating opportunities for new life forms to emerge. Moreover, Studying the Kuiper Belt helps us understand the broader processes that shaped our solar system. The icy bodies in this region are like time capsules, preserving materials from the early days of planetary formation. By analyzing these objects, scientists can piece together how water and organic molecules were distributed throughout the solar system, shedding light on how Earth became the vibrant, life-sustaining planet it is today. The Kuiper Belt's influence on Earth is a reminder of how interconnected our solar system truly is. What happens in this distant region can have ripple effects that reach all the way to our own planet. As we continue to explore the Kuiper Belt, we uncover not only the secrets of this icy frontier, but also the profound ways it has shaped our home in the cosmos. This cosmic connection underscores the importance of studying these distant worlds, as they hold the keys to understanding our own origins and the delicate balance that sustains life on Earth. As we shift our gaze to the ever-changing nature of the Kuiper Belt, we uncover a dynamic region that is far from static. This distant frontier, often imagined as a frozen, unchanging expanse, is in fact a place of constant motion and transformation. The Kuiper Belt's landscape is shaped by powerful gravitational forces, interactions between its objects, and the subtle yet persistent influence of the Sun's gravity, even at such vast distances. One of the key factors driving this evolution is the gravitational interplay between Kuiper Belt objects and the giant planets, particularly Neptune. As these icy bodies orbit the Sun, Neptune's gravity can nudge them into new paths, sometimes sending them inward toward the inner solar system or outward into even more distant regions. These interactions can create chaotic orbits, leading to collisions, ejections, or the formation of new groupings of objects. Over time, these gravitational dances reshape the structure of the Kuiper Belt, creating a region that is both ancient and ever-changing. Another fascinating aspect of the Kuiper Belt's evolution is the role of collisions. While the distances between objects are vast, collisions do occur, and they can have significant effects. When two Kuiper Belt objects collide, they can break apart, merge, or even form new moons. These events not only alter the physical makeup of the region, but also provide clues about the early solar system. By studying the debris from these collisions, scientists can learn more about the processes that shape the Kuiper Belt and the materials that make up its icy inhabitants. The Kuiper Belt's changing landscape also holds the promise of future discoveries. As our technology advances and our understanding deepens, we are likely to uncover new objects, moons, and even phenomena that challenge our current knowledge. For example, the discovery of the Kuiper Cliff, a sudden drop-off in the number of objects beyond a certain distance, has sparked theories about the existence of an undiscovered planet or other unseen forces at work. These mysteries remind us that the Kuiper Belt is a region full of surprises, waiting to reveal its secrets to those who dare to explore it. Looking ahead, the Kuiper Belt's dynamic nature ensures that it will remain a focal point of scientific inquiry. Each new discovery adds another piece to the puzzle, helping us understand not only this distant region, but also the broader story of our solar system's formation and evolution. As we continue to study the Kuiper Belt, we are reminded that even the most remote corners of our cosmic neighborhood are alive with activity, constantly reshaping themselves and offering new insights into the universe we call home. As we venture deeper into the mysteries of the Kuiper Belt, we find ourselves standing at the edge of one of the most intriguing questions in modern science: the connection between this distant region and the enigmatic substance known as dark matter. While the Kuiper Belt is a realm of icy bodies and dwarf planets, its study might hold clues to understanding something far more elusive: dark matter, the invisible force that makes up a significant portion of the universe. Dark matter, though it cannot be seen or directly detected, exerts a gravitational influence on the visible universe. Its presence is inferred from the way galaxies rotate and how light bends around massive objects. But what does this have to do with the Kuiper Belt? Scientists have begun to speculate that the peculiar orbits of some Kuiper Belt objects might be influenced by the gravitational pull of dark matter. These objects, which sometimes follow paths that defy expectations, could be subtly tugged by the unseen hand of dark matter, offering a rare opportunity to study its effects. One of the most compelling theories suggests that dark matter could be concentrated in certain regions of the solar system, including the outer edges of the Kuiper Belt. If this is true, the way Kuiper Belt objects move and interact could provide indirect evidence of dark matter's presence. For example, the unusual orbits of objects like Sedna, which travels far beyond the Kuiper Belt on an elongated path, might be shaped by the gravitational influence of dark matter. By carefully mapping these orbits, scientists hope to uncover patterns that point to dark matter's role in shaping the outer solar system. Studying the Kuiper Belt also offers a unique laboratory for testing theories about dark matter. Some researchers propose that dark matter particles could collide with Kuiper Belt objects, leaving behind subtle traces or altering their surfaces in ways that could be detected by future missions. While this remains speculative, the possibility opens up exciting avenues for exploration. Missions like New Horizons, which has already provided stunning insights into the Kuiper Belt, could be adapted to search for these elusive signatures. The connection between the Kuiper Belt and dark matter is still in its early stages of exploration, but it represents a fascinating intersection of planetary science and cosmology. By studying this distant region, we might not only learn more about the origins of our solar system, but also gain insights into one of the greatest mysteries of the universe. As we continue to probe the Kuiper Belt, we are reminded that even the most remote corners of space hold the potential to reveal profound truths about the cosmos. And with each discovery, we move closer to unraveling the secrets of dark matter and its role in the grand tapestry of the universe. Now, as we turn our gaze toward the future, the Kuiper Belt emerges not just as a relic of the solar system's past, but as a frontier brimming with possibilities for space exploration. This distant region, with its icy bodies and dwarf planets, holds the key to answering some of the most pressing questions about our cosmic neighborhood. Future missions to the Kuiper Belt could unlock secrets about the formation of planets, the origins of water and organic molecules, and even the potential for life beyond Earth. One of the most exciting aspects of exploring the Kuiper Belt is the opportunity to study objects that have remained largely unchanged since the birth of the solar system. These icy worlds are like time capsules, preserving clues about the conditions that existed over 4.5 billion years ago. By sending spacecraft to investigate these objects, scientists hope to piece together the story of how our solar system evolved and how planets like Earth came to be. Missions like New Horizons, which gave us our first close-up look at Pluto and Arrokoth, have already shown us just how much we have yet to learn. But the Kuiper Belt isn't just about looking back in time. It's also about looking forward. As we plan future missions, we're faced with questions that could reshape our understanding of the universe. For instance, what can the Kuiper Belt tell us about the distribution of water and other volatiles in the solar system? Could some of these objects harbor subsurface oceans, similar to those suspected on moons like Europa and Enceladus? And if so, what might that mean for the search for life? These are the kinds of questions that drive scientists and engineers to design missions capable of reaching these distant worlds. The challenges of exploring the Kuiper Belt are immense. The vast distances, extreme cold, and limited sunlight make it one of the most difficult regions to study. Yet, these challenges also make it one of the most rewarding. Every mission to the Kuiper Belt pushes the boundaries of technology and human ingenuity. Advances in propulsion, communication, and instrumentation will be essential to unlocking the secrets of this distant frontier. And with each new mission, we inch closer to answering questions that have puzzled us for decades. Beyond the scientific discoveries, the Kuiper Belt also represents a stepping stone for humanity's broader ambitions in space. As we look to explore beyond our solar system, the Kuiper Belt offers a testing ground for technologies and strategies that could one day take us to the stars. It's a reminder that even the most remote corners of our cosmic backyard hold lessons that could shape the future of space exploration. As we continue to dream of what lies beyond, the Kuiper Belt stands as a beacon of discovery, inviting us to explore, to question, and to imagine. With each mission, we not only uncover the secrets of this distant region, but also take another step toward understanding our place in the universe. And as we do, we are reminded that the journey of exploration is never truly complete. It's a story that unfolds with every new horizon we reach. Now, as we venture deeper into the Kuiper Belt, let's uncover some of its hidden gems, objects that may not be as famous as Pluto or Eris, but are no less fascinating. Among these lesser-known worlds are Varuna, Ikshan, and Orcus, each with its own unique story and characteristics that make them stand out in this icy frontier. Varuna, named after the Hindu deity of water and the celestial ocean, is a large Kuiper Belt object with a diameter of roughly 700 kilometers. What makes Varuna particularly intriguing is its rapid rotation, completing a full spin in just under 6 hours. This fast rotation gives it an elongated, almost egg-like shape, a feature that sets it apart from many other objects in the region. Scientists believe Varuna's surface is covered in a layer of frozen methane, ethane, and nitrogen, making it a cold, reflective world that glimmers faintly in the distant sunlight. Next, we encounter Ixion, a reddish-hued object named after a figure from Greek mythology. Ixion's reddish color suggests the presence of complex organic molecules, known as tholins, on its surface. These compounds form when ultraviolet light interacts with methane and other simple hydrocarbons, creating a reddish-brown coating. Ixion's orbit is also noteworthy, as it lies in a region of the Kuiper Belt, where gravitational interactions with Neptune have shaped its path. This makes Ixion a fascinating subject for studying how the giant planets have influenced the dynamics of the outer solar system. Then there's Orcus, often referred to as the anti-Pluto, due to its orbital similarities to Pluto. Orcus and Pluto are locked in a kind of cosmic dance, with their orbits mirroring each other across the solar system. Orcus is also notable for its moon, Vanth, which is relatively large compared to its parent body. The presence of Vanth raises questions about how such moons form in the Kuiper Belt and what role they play in the evolution of these distant worlds. Orcus itself is thought to have a surface rich in water ice, with possible traces of ammonia, hinting at a complex and dynamic history. These hidden gems of the Kuiper Belt remind us that even in the farthest reaches of our solar system, there is no shortage of wonders to discover. Each object, with its unique features and mysteries, adds another piece to the puzzle of how our cosmic neighborhood came to be. As we continue to explore this distant region, we are constantly reminded that the Kuiper Belt is not just a collection of icy rocks. It's a treasure trove of stories waiting to be told. And with every new discovery, we gain a deeper appreciation for the complexity and beauty of the universe we call home. As we shift our gaze to the stars and the mysteries they hold, let's consider an intriguing question. Could the Kuiper Belt hold clues to the existence of extraterrestrial intelligence? While this icy region is often associated with ancient remnants of our solar system's formation, some scientists speculate that it might also serve as a potential site for detecting signs of alien civilizations. The vast distances and relative isolation of the Kuiper Belt make it an unconventional but fascinating place to search for such evidence. One possibility is that advanced civilizations might use the Kuiper Belt as a kind of cosmic outpost or storage facility. Its remote location, far from the sun's interference, could make it an ideal spot for placing long-term observational equipment or even artifacts meant to endure for millennia. If such objects exist, they might be designed to withstand the harsh conditions of space, preserving information or technology for future discovery. The challenge, of course, lies in identifying these potential signals or artifacts among the countless icy bodies that populate the region. Another angle to consider is the idea of directed energy signals. Some theories suggest that extraterrestrial civilizations might use the Kuiper Belt as a relay point for interstellar communication. By positioning transmitters or receivers in this distant region, they could minimize interference from the sun and other sources of noise. Detecting such signals would require advanced technology and a deep understanding of the Kuiper Belt's environment, but the implications of such a discovery would be profound. It could provide the first concrete evidence that we are not alone in the universe. However, the search for extraterrestrial intelligence in the Kuiper Belt is not without its challenges. The sheer vastness of the region, combined with the dim light and extreme cold, makes it a difficult place to explore. Current missions, like New Horizons, have provided valuable data, but they are limited in scope. Future missions equipped with more sophisticated instruments will be necessary to thoroughly investigate the possibility of alien artifacts or signals. Even then, distinguishing between natural phenomena and potential signs of intelligence will require careful analysis and a healthy dose of skepticism. The implications of discovering extraterrestrial intelligence in the Kuiper Belt would be nothing short of revolutionary. It would not only reshape our understanding of the universe, but also challenge our place within it. Such a discovery could spark new questions about the nature of life, the origins of technology, and the potential for interstellar communication. It would remind us that the Kuiper Belt, often seen as a relic of the past, might also hold the key to humanity's future. As we ponder these possibilities, we are reminded that the search for extraterrestrial intelligence is as much about curiosity as it is about science. The Kuiper Belt, with its icy mysteries and distant horizons, invites us to dream of what might lie beyond our current understanding. And while the answers remain elusive, the journey itself is a testament to our enduring desire to explore the unknown. Now, as we turn our gaze back to Earth, let's explore how ancient cultures might have interpreted the Kuiper Belt and its enigmatic objects. While these distant icy worlds were far beyond the reach of early astronomers, their influence on human imagination and storytelling is a fascinating topic to consider. Ancient civilizations often looked to the skies for meaning, weaving myths and legends around the celestial bodies they observed. Could the Kuiper Belt, though unseen, have inspired some of these tales? In many cultures, the night sky was a canvas for storytelling, filled with gods, heroes, and cosmic events. The Greeks, for example, personified the planets and stars, creating intricate myths to explain their movements and significance. While they couldn't see the Kuiper Belt, its icy inhabitants might have been imagined as distant realms or hidden worlds, perhaps even as the homes of gods or spirits. The idea of a faraway, mysterious place beyond the known planets resonates with many ancient myths about the edges of the universe. Similarly, the Norse myths speak of Yggdrasil, the great world tree, whose branches extend into the heavens and whose roots reach into the underworld. The Kuiper Belt, with its icy bodies and distant orbits, might have been seen as a kind of cosmic boundary, a place where the known world ended and the unknown began. This concept of a frontier, both physical and spiritual, is a recurring theme in many ancient traditions. In Mesoamerican cultures, the heavens were often associated with cycles of creation and destruction. The Kuiper Belt's icy objects, remnants of the solar system's formation, could have been interpreted as fragments of a primordial world, pieces of a cosmic puzzle left behind after the gods shaped the universe. The idea of these distant bodies holding secrets about the origins of life and the cosmos aligns with the deep curiosity ancient cultures had about the stars. Even in cultures that didn't have advanced astronomical tools, the night sky was a source of wonder and inspiration. The Kuiper Belt, though invisible to the naked eye, might have been imagined as a realm of mystery and possibility. Its icy worlds could have been seen as the homes of ancestors, spirits, or otherworldly beings, places where the boundaries between the physical and the spiritual blurred. As we reflect on these ancient interpretations, we're reminded of the timeless human desire to find meaning in the cosmos. The Kuiper Belt, with its hidden secrets and distant horizons, continues to inspire us, just as it might have inspired the storytellers of old. And while we now understand it through the lens of science, its connection to our shared cultural heritage adds another layer of wonder to this icy frontier. With this in mind, let's now turn to the future of the Kuiper Belt, exploring how this distant region might shape our understanding of the solar system and beyond. As we cast our gaze toward the horizon of possibilities, the future of the Kuiper Belt holds both immense promise and profound questions. This distant region, brimming with icy bodies and ancient remnants of the solar system, could become a frontier for resource extraction, scientific discovery, and perhaps even human exploration. But what might this future look like, and what challenges would we face in reaching it? One of the most intriguing prospects is the potential for resource extraction. The Kuiper Belt is rich in frozen volatiles like water, methane, and ammonia, which could serve as vital resources for future space missions. Water, for instance, could be split into hydrogen and oxygen to create rocket fuel, enabling spacecraft to refuel on long journeys. Methane and ammonia might also be used for energy or as raw materials for manufacturing in space. However, the logistics of mining these distant objects are daunting. The vast distances, extreme cold, and lack of infrastructure make such endeavors a monumental challenge, requiring advancements in robotics, propulsion, and sustainable technology. Scientific exploration, on the other hand, is already underway, with missions like New Horizons providing our first close-up views of Kuiper Belt objects. Future missions could delve even deeper, studying the composition, structure, and history of these icy worlds. Each object holds clues about the early solar system, offering insights into how planets formed and evolved. Some scientists even speculate that certain Kuiper Belt objects might harbor subsurface oceans, raising the tantalizing possibility of finding extraterrestrial life. The pursuit of such discoveries could drive a new era of exploration, pushing the boundaries of our knowledge and technology. Human colonization of the Kuiper Belt, while still a distant dream, is not beyond the realm of possibility. Establishing a presence in this remote region would require overcoming significant hurdles, from developing life support systems capable of sustaining humans in such an extreme environment to creating self-sustaining habitats that can operate independently of Earth. The psychological and social challenges of living in such isolation would also need to be addressed. Yet, the idea of humans venturing into the Kuiper Belt speaks to our enduring spirit of exploration and our desire to expand our horizons. Of course, these possibilities come with ethical considerations. Should we exploit the resources of the Kuiper Belt? And if so, how do we ensure it is done responsibly? What impact might human activity have on these pristine, ancient worlds? And who gets to decide how these distant regions are used? These questions remind us that the future of the Kuiper Belt is not just a matter of technology and ambition, but also of ethics and stewardship. As we ponder the future of this icy frontier, one thing is clear: the Kuiper Belt holds the potential to transform our understanding of the solar system and our place within it. Whether through resource extraction, scientific discovery, or human exploration, this distant region invites us to dream boldly and act thoughtfully. And as we continue to explore its mysteries, we are reminded that the cosmos is not just a place of wonder, but also a canvas for our aspirations. As we bring our journey through the Kuiper Belt to a close, let's take a moment to reflect on the wonders we've uncovered. This distant region, stretching far beyond Neptune, is more than just a collection of icy bodies. It's a treasure trove of secrets waiting to be unlocked. From the enigmatic dwarf planets like Pluto and Eris to the peculiar shapes of Haumea and Arrokoth, each object tells a story of the solar system's earliest days. The Kuiper Belt is a cosmic time capsule, preserving the building blocks of planets and offering clues about how our celestial neighborhood came to be. We've explored the challenges and possibilities of future exploration, from mining its frozen resources to searching for signs of life beneath icy surfaces. The Kuiper Belt is not just a scientific frontier, it's a reminder of humanity's boundless curiosity and our drive to explore the unknown. As we look to the stars, we're reminded that the universe is vast, filled with mysteries that inspire both awe and humility. So, as you drift off to sleep tonight, let your mind wander among these distant worlds. Imagine the icy plains of Pluto, the elongated shape of Haumea, or the snowman-like form of Arrokoth. Picture the Kuiper Belt as a realm of endless discovery, where every object holds a piece of the puzzle that is our solar system. And as you dream, remember that the cosmos is not just a place of wonder, it's an invitation to explore, to learn, and to dream boldly. Thank you for joining us on this journey through the Kuiper Belt. If you enjoyed this exploration of the universe's hidden secrets, don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss an adventure into the cosmos. Until next time, keep looking up and let the stars guide your dreams. Good night. you.